This question is question 12 from the 2022 MCAS exam, and it's reviewing our rules of exponents. Now, on our MCAS Google Classroom, there is a separate video that explains all the rules of exponents. So if you need some review on that, on all the rules, definitely go check that out. But this one specifically has, you'll notice that I have exponents raised to a power, okay? And the rule for that is just to multiply the two exponents, okay? And I'll explain to you why that works, okay? So if I have x cubed and y to the fifth, and I'm raising that whole thing to the fourth, that means I have 4 of these. I have 4 groups of these. Okay, so to find the total number of x's, I add all of my exponents together. So this is 3, 6, 9, 12. And if you'll notice, 3 times 4 is 12, okay? So that's why we're multiplying each set. So, and again, with 5, I have 5, 10, 15, 20. 5 times 4 is 20. So that's why we multiply, any exponents raised to a higher power. Okay, so yes, so that gives us x squared y to the 20. Now here, this portion, we have a negative exponent, okay? Now we are going to raise both x cubed and y squared to the second power. So I'm going to have 2 groups of x cubed y squared. Okay. Which will give me a total of, because 3 times 2 is 6. So this is x to the 6th, y to the 4th, because 2 times 2 is 4. But because of that negative, what that does is it makes it a fraction. So actually what we're doing is we're putting all of this over 1. So technically what we have is x to the 6th, y to the 4th. We have that. And let me fix this right here, because I'm supposed to be x to the 12th. So it's x to the 12th, not x to the 2nd. I made a mistake there when I wrote this down. Okay, so x to the 12th, as I miswrote it. Okay. So now, fractions, remember fractions are the same as division. So when we're dividing exponents, we actually subtract those exponents. And the reason for this is that, now I'm not going to write out all 12, okay, but okay, I got 6 in the denominator, because x to the 6th is x times x times x times x times x times x. Okay, 6 x's. Okay, and imagine I have 6 more on the top. Okay, every x in the numerator cancels one with in the numerator cancels with the denominator, because anything divided by itself is 1. Okay, so when I do 12 minus 6, I get 6. Okay, I have 6 left after I cancel out the 6 of the 6 in the numerator, 6 in the denominator. Okay, so that's why we subtract the exponents. And then for y, it's going to be 20 minus 4, which which gives me 16. Okay, so that would be the final answer for that question. This question number 18, similar along the lines of we have exponents raised to a power, but what's slightly different here is that my n cubed is underneath the square root. So there's two ways we could approach this. Let's first, so if I have the square root of n cubed and I'm raising that to the 4th power, that means I have 4 of them. Okay. Now, so what that means is that technically, I have n to the 12th. Okay, since all of them are underneath the square root, I can add up or multiply extended addition, or do 3 times 4, which is 12. So I do have n to the 12th. But when we have a square root, although it's not written, there's this index, what we call this number here, this index of 2. Okay. And it's the same reason why we know 25, the square root of 25 is 5. It is because 5 times 5 is 25. Okay, so you notice any pair of the same number is equal to that number, 5, okay? Because the square root asks the question, what number times itself gives us 25, okay? So I can, if I have 12 n's and I pair them up, okay, I can create 6 pairs, right? Okay, that would be one pair of n's gives me n, and then another pair of n's gives me n, okay? And then obviously another pair of n's gives me n. So I have 6 pairs. So that would give me 6 n's, or n to the 6th, okay? Another way that you could look at this is there is such a thing as fractional exponents. So if I have the square root of n to the 12th, that is the same as n to the 12 over 2. Okay? The number on the inside goes in the numerator, the number on the outside goes in the denominator, and 12 divided by 2 does give me n to the 6th. Okay, so again, depending on how you want to approach this, okay, you can break it down into groups like I did here, okay, because those are my 12 n's. 2, 4, 6, 8, 10, 12. And every pair of n's, just like here, every pair of 5s gives you a 5. This gives me my 6 n's. Or you can approach it from this fractional exponent. Okay? And then part B expands on this fractional exponent. Okay? So, oh boy. Okay, so we have x, obviously, and that's to the 1st power, because even though it's not written. And then this x to the fourth, the fifth root of x to the fourth, we would write as x to the 4/5. Okay. Now, we're multiplying these, okay? So the 4/5 comes, okay, the power that the variable is raised to goes in the numerator. The root, or the index number, this, goes in the denominator, okay? Now we're multiplying, okay? And when we multiply, we add exponents, okay? So as to show a simpler example, okay? If I have x cubed times x squared, okay, that's the same as x to the 3 plus 2, or x to the 5th. Okay, why is that? Because x cubed is x times x times x, and x squared is just x times x. And if you'll notice, I have 5 x's, so that's how I get x to the 5th. So that's why we add our exponents when we multiply. The tricky thing here is that I have a whole number 1 and I have a fraction, okay? So what we need to do is do 1 plus 4/5. Okay, well obviously that's 1 and 4/5. But again, I need this as like a whole number. So we can convert any mixed number that we call by multiplying the whole number, the denominator times the whole number, so 5 times 1 is 5, and then adding the numerator to give me 9/5. Okay? Or I can convert 1, the whole number 1, into 5/5. Okay? Because it represents a whole. Because when you are adding fractions, you have to have a common denominator. So if I take my whole number 1 and just make it 5/5, 5/5 is a whole, and then add the 4/5 to it, 5 plus 4 is 9, so that's 9/5. And that would be our final answer there.